in recent years, with the change of the environment and the emergence of more extreme weather, such as continuous high temperature, sudden heavy rain, typhoon, and so on, more and more people began to pay attention to the relationship between the ecological environment and human society. And many countries have formulated the goal of reducing carbon dioxide emissions and reducing environmental pollution. The transport sector is responsible for 10 to 15% of carbon dioxide. Carbon dioxide emissions each year. Therefore, reducing the carbon emissions of the transportation industry plays a crucial role in the overall energy conservation and emission reduction. As a result, in the entire transportation industry, a wave of energy conservation and emission reduction has also set off a big discussion. The United Nations 17 Sustainable Development Goals has also have many aspects related to environmental protection, such as climate action, ocean action, and terrestrial ecological protection. Based on this, we will start from the transportation of maternal and child products manufacturers to find a more efficient, more convenient, and greener supply chain downstream transportation in response to the Sustainable Development Goals ensured by the United Nations, inject new vitality into the transportation ecological environment, and also hope to provide a new development idea for the enterprises. At present, the downstream product transport mainly uses two models of transport. One is floor transport, the other is pallet transport. These two kinds of transportation have some common problems, such as the trunk inside the box accumulation is not tight, resulting in reduced transportation efficiency, inconvenient for store clerks to load, unload, and disassemble. Due to the extrusion collision caused by the transportation process, the loss of goods is larger and the other series of problems. We carefully analyzed and reviewed the possible problems and further purposed our group thinking with a view to solving the above problems. We want to size small containers with handle made of weight, environmentally friendly, composite materials. Small containers can be lifted easily and conveniently, but can also be packed tightly inside the trunk without wasting space. For the material of the box, we will use a recyclable and environmentally friendly material. Each container has a separate identification code, which has solved the quality control problem in the last kilometer transportation process, realized the whole process supervision, and further ensured the quality of product transportation. When the container is not in use, the box can be folded up without taking up too much space. Next, my teammates will further introduce the creative sources of boxes, product design, and container system workflow. Okay.
Next, I would like to introduce the inspiration behind our idea and the design of our product. Our concept came from the challenge. Our concept came from the challenges in downstream transportation and the current requirements for efficiency and sustainability. In the last mile delivery, where the goal is point-to-point distribution, both pallet loading and floor loading seem impractical choices, while pallet loading ensures orderly stacking and protects goods from squeezing. The pallet sizes often differ from those trucks, leading to space waste and a decrease in transportation efficiency. Additionally, the lack of forklifts for unloading pallets in stores leads to increased handling costs, time consumption, and logistic challenges. Floor loading. Floor loading increases the amount of goods loaded per trip, enhancing space utilization. However, it raises the likelihood of goods colliding with each other and increase the risk of moisture damage in non-sealed environments, leads to a higher rate of goods damage. Therefore, there is a crucial need for a completely new container system customized for downstream transportation. Our vision involves designing a novel, low-cost, and affordable container system. The container body uses high-strength composite materials and is designed to be foldable. Additionally, the container is sealed, effectively dust-proof and waterproof. In terms of specific design, the container bottom is equipped with small ropes, suitable for sliding on the ramp during loading and unloading. Due to material's good load-bearing ability, the containers can be stacked, ensuring optimal space utilization. The container is equipped with positioning facilities to easy cargo tracking and management during actual distribution. We propose one case, one store. That means goods from different stores are separately loaded and unloaded.
The following describes the operational process of our downstream container system. So from the case study given by Baymax, we know that downstream transportation is basically a circular logistic process from the end warehouse to each physical store. First, the store sends an order to the warehouse based on its own demand for goods, and the warehouse accepts the demand and loads the products into empty containers in advance for transportation. Each order has a unique code affixed to the container, and by identifying these markers at each step of the transportation process, customers can easily know the shipping status of their order. Unmanned and automated packaging and identification systems are a promising direction in this process. So before the truck is dispatched, the container is loaded into the van via a forklift. Upon arriving at the store, they are quickly unloaded via the tailgate of the truck. The store organizes the container's goods themselves, and the driver can move on to the next store, greatly improving transportation efficiency. Finally, after the store gets the goods, the empty containers can be folded up and returned to the truck for the next delivery and recycled.
Last part, I will introduce our product's advantages, timeline, and prospect. The container's unique points may include the following. First is a lightweight design. The use of high-strength composite materials instead of traditional steel materials make it lighter in weight, which reducing energy consumption and carbon emissions during truck transportation. Then the case is foldable, so it saves time and space in the whole process of transportation. Another unique aspect is about the products is recyclable so that it releases the resource consumption and the burden on the environment. What's more, we design a handle on each container, so it's labor saving to unload them from trucks. We think our idea has a high probability of success due to the following reasons. First of all, the products of Baymax will have consistent and stable needs, and our products will respond to social needs as a high concern of the health of mothers and babies. In addition, comparing with the existing loading method, our design can bring more economical and environmental benefits, so it has high sustainability. Last but not least, our idea have high feasibility from the perspective of materials and technology. As for the timeline of our plan, it will undergo 4 steps before it finally comes into reality. First, we may spend 1 week to research the quantity of goods of each customer's need and calculate the size of containers we will design to avoid time waste in picking the cargo. The next step is to produce some container samples according to our calculations for about 2 weeks. In the following step, we will take 1 month to test the new container's tolerance to long distance and the weight of goods by imitating true transportation. In the final step, we need 1 month to optimize the design of the containers according to the problems found in the trial operation stage and expand the production for officially put into use. So our idea can be turned into implementations for about 3 months later. After proposing the system, our next steps include: first, technical development. The technical details of the foldable container system need to be further studied to meet the need of transportation. Then, to make the system further operational, Babymax need to establish a manufacturing and distribution network to produce and supply these foldable container systems. Then the company needs to develop marketing strategies and improve competence of the products, taking some measures to attract potential customers and promote the adoption of the system in downstream transportation. Finally, establish a new downstream system network. Establish a partnership with relevant industries, such as transport companies, manufacturers, retailers to form a new downstream network and expand influence. That's all of our presentations. Thank you for your listening.
That's all for our presentation. Yeah.
Thank you.
Okay, so is that time for question now? We lose contact.
I think yes.
Yeah, we lose the contact with the host.
Yeah.
I see his picture. I see his video. Maybe we
Yeah,
should. Why don't we go ahead and just start asking them questions? You know.
Okay, great. Okay, so should I? I have 2 questions to ask.
Yes.
Thank you. First question is about the carbon reduction using this method of foldable plastic container system. Have you estimate how much in percentage that this method can reduce carbon compared with the traditional pallet method? If you compare the 2 methods, you know, will this reduce more carbon or similar carbon?
You mean the specific percentage between? So first, in material selection, we choose lightweight, environmentally friendly plastic materials and degradable materials and recycle them. So, and for the transportation part, our point-to-point customized distribution can decrease the transportation times compared to the original ones.
Yes.
Okay. I think you got the structure approximately right. If you think of the reduction of carbon, so for sure, you are going to consider the material, because from the material, you're going to make the container system. The secondary is the transportation, and that's to do with the weight of the container compared with the pallet, right? Third is the labor handling. You shouldn't mix up the handling with transportation because they are two different things.
Yeah.
I'm right? Okay. Then the last one is in the recycling. I would suggest to look into these 4 categories to compare the amount of reduced carbon between the 2 different approaches. Okay. Now, another question. I read your written materials, in which you say that the success rate for this method is about 90%, 90. Where this 90% come from? Did you calculate by mathematic formula to get this 90% success rate? Or how much you think this method will be, successful?
Yes.
I haven't do calculation in mathematics, but from my point of view, I think our idea have some visibility in some extent. But we haven't do some experiments, and there may be some disadvantages in our methods. So we think 90% of successability is suitable.
All right, so the 90% is just assumption. It's not yet been validated or tested, right?
Yes.
Okay, good. Yeah, I have no more questions.
Okay, thank you,
Thank
Doctor.
you. Thank you. Thank you.
Richard, do you have questions?
Yeah, I had a couple of questions, and I guess I'd like to say thank you very much for the presentation. Very, very clear and easy to follow and understand. I had the same question that was asked previously about the carbon saving, and I was wondering whether the more efficient use of the space in the truck would result in fewer trips, and if you had looked at that aspect of the carbon saving.
Because the size of containers is suit for the size of the carriage, so we can reduce the times in the transportation.
Oh, so when you say reducing the time, you mean the number of trips then?
Yeah.
Yeah.
I see.
Yeah,
Okay.
our containers can be in different sizes, corresponding size container.
Uh-huh.
So we will base on the order quantities survey and design several sizes of boxes. So if the order values is too large, it is divided into several containers, but one box corresponds to one store. no mixing. Yeah.
So, is it your idea that the containers would be unloaded while the truck is waiting? In other words, the containers would be taken off the truck at the destination, and then the contents of the containers would be removed and the container would be put back on the truck? Or would you be leaving the containers at the customer store and then coming back later to pick them up?
Yeah, the empty container can be folded up until the next delivery can be returned to the warehouse.
So it wouldn't be there's a term live unloading, which means the truck has to wait for the unloading to take place. But in this case, it wouldn't have to wait. You would leave the boxes there. Yeah. And then come back the next trip and pick up the empties that have been folded up. Is that right?
Yeah.
Yeah, very
Yes,
clever
yes.
solution. And what kind of changes would be needed for the trucks? Would you need to change the configuration, the design of the trucks, or could you use the existing trucks?
So if the truck don't come with the tailgate or something to fit our system.
Because we unload the goods. When we unload the goods, we need to slide the containers on the ramp. So if the truck doesn't have the ramp, we may need to add one. If the truck doesn't have the handles, we may switch to a different one that have the handles.
Then the truck will be equipped with a slope, so we can unload the cargoes from the slope, so it is labor saving.
So have you thought about the cost of the project, of the financial investment that would be required?
So I think the initially require the relatively large cost investment to set up the container distribution system, and the whole system can reduce the cost of each transportation in the later stage after the system is established.
You know, what helps in selling a case like this is for the customer to see what the return is on the investment. What you're saying, I think, is that there would be an upfront cost, but that this would be recovered because it would be more efficient in the future.
Yeah.
Right.
So
Yeah.
maybe at the beginning of our project, we will cost more compared to other projects. But if we establish the whole system, we can reduce the cost of the transportation. So that's our that's our I'm thinking over to describe the situation. Maybe that's our
advantage.
Yes, that's our advantage. Yeah.
Thank you.
My English is very poor.
No, it's quite good, actually. I guess one last question is, have you thought about how to get the customers to accept this new system? because they would have to train employees in the unloading and folding and return process. It would mean a whole new process for their people to be part of the system. So have you thought about how to get the customers to accept the change in the way they're doing business?
So in my opinion, I think if we establish the whole project, we should teach our customers and teach our employees to learn how to use our systems, because it can reduce the cost of the transportation in the later time, and also contribute to our environment. And so I think it's our duty and responsibility to do these things. Yeah.
And I think our whole system is not that hard to understand, and I think it's understandable.
Okay, thank you very much.
Okay, well, thank you, Richard. I'll just leave the last questions for Dr. Huang. Dr. Huang, do you have any questions for the students? Dr. Huang, are you? Okay, I don't hear an answer. So I'm guessing that means there's no other questions. So thank you very much for the judges as well as the students for a very interesting presentation. And we hope to hear the results probably this time next week. So thank you very much.
Thank you.
Thank you. Thank you, Professor.
Thank you, Professor.
Thanks
Bye-bye.
a lot. Very interesting.
Thank you very
Bye-bye.
much, and good work. Good work.
Yes.
Thank you.